This is video 2A for the Year 7 Mathematics course. In this video, we're going to be covering the theory behind square numbers under the topic of number properties. Specifically, we are going to explore the definition of a square number, i.e. a perfect square, how to calculate square numbers, square roots, and then we're going to cover some example questions. Alrighty, let's talk about square numbers. Now, the really nice thing about square numbers is that even if you maybe haven't actually heard of the phrase square numbers before, you've more than likely seen square numbers actually appear in one way or another. And again, the really nice thing about square numbers is that the idea behind them is very, very simple as well. So first of all, let's write out a very, very straightforward, easy to understand definition of a square number. Now, effectively, a square number is the result of when you multiply a whole number, or in other words, a natural number, by itself. And sometimes, depending on what type of teacher you have, they may refer to square numbers as perfect squares. So we have to understand that perfect squares and square numbers mean the exact same thing. Or in other words, another way that you can think of the definition of a square number is that a square number is a number that is produced by multiplying a natural number by itself. So, two different ways of saying the exact same thing, but in essence, it's this idea that square numbers are effectively numbers that are the result of when you multiply a natural number, or in other words, a positive whole number, by itself. Now, just as a little bit of added terminology here as well, in maths, the phrase squaring a number is the process of multiplying a number by itself. So I'm sure you can probably see the connection between the idea of squaring a number and the name a square number. So an example of this could be if you get the number 7 and you multiply it by itself, or in other words 7 times by 7, we would say that this is equivalent to 7 squared. And in order to write this in a more mathematical sense, we write 7 with a little 2 in the top right hand corner. Effectively, what this 2 here represents is the idea of multiplying this 7 by itself twice. The other way that we can say this is a power of 2. However, typically whenever we're referring to the power of 2, we often just say squared. And so what this effectively means is that square numbers can be calculated by performing the following calculations. So all we do here is we grab all of the natural numbers, in other words, all the positive whole numbers, and we square them, and then we see what the result is. So the first natural number is 1, so we'll do 1 squared, or in other words, 1 multiplied by 1, which is of course equal to 1. Then the next one, 2 squared, is equal to 2 multiplied by 2, which is of course 4. Then the next one, 3 squared, is 3 by 3, which is 9. Next one, 4 squared, which is 4 by 4 is equal to 16. And now we're just going to continue this pattern up until about 10 squared. Now, just for the sake of this video, I'm just going to stop here at 10 squared. However, what we need to understand is that realistically, there is a never-ending amount of square numbers because we can continue this to 11 squared, 12 squared, up until a million squared, and then we can just keep going and going and going. However, under the scope of this course, we're mainly going to be dealing with the first 10 square numbers. So mainly this set of numbers here. However, it is important to understand that this list just keeps going on and on and on. Now, from this list, what we can effectively gather is that 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are the first 10 square numbers, because these all result from 1 squared, 2 squared, 3 squared, 4 squared, up until 10 squared. Now, as an extra part of this course as well, we will be discussing this idea of a square root. We will be focusing on the idea of square rooting numbers a lot more in a different chapter. However, for now, we'll just introduce it very, very briefly because it does have a very, very strong impact on this discussion of square numbers. Now, effectively, the idea of square rooting a number is the complete converse of squaring a number. It means we start with one of these square numbers here, so again, whether it be 1, 4, 9, yada yada yada, and the impact of square rooting gives us the original number, such that when you multiply that original number by itself, you get that perfect square. And the really nice thing about square rooting square numbers is that the result will always be a whole number. So for example, if we had the square root of 25, effectively what we're being asked here is what number do we have to multiply by itself to give us 25, which is of course equal to 5. Square root of 81 will be similarly equal to 9. Square root of 9 is equal to 3, and we go on from there. But what we notice here is that whenever we square root one of these perfect square numbers, the answers are always whole numbers. So again, in the context of square numbers, the idea of square rooting is effectively just the complete contrast. Now, just as a bit of terminology here as well, what we would say in these, for instances, is that 5 is the square root of 25, 9 is the square root of 81, and 3 is the square root of 9. So let's write that here. Okay. Now, before we get into a couple example questions around this idea of squares and so on, I just want to actually give you a bit of a fun fact about why we actually refer to these numbers as square numbers. And the reason being is because we can always represent these square numbers as an array of dots that are arranged in a square. So just as a very, very quick example, if we first of all consider 1 squared, this is of course equal to 1, which can be represented by a single dot. What about 2 squared? We have 2 squared is equal to 4, and we can represent this by a square, which has 2 dots by 2 dots. And then furthermore, we've got 3 squared, which is of course equal to 9, which can also be represented as a square, which is 3 dots by 3 dots. And so we can see that in all three of these situations, these dots have been arranged into squares, hence the name square numbers. Now, with that being said, let's get into a few example questions about how we can use square numbers. Alright, so the first example that we're going to do here is to calculate 8 squared and 11 squared. So starting off with 8 squared, we of course know that 8 squared is equivalent to 8 multiplied by 8, which is equal to 64. Furthermore, 11 squared is equivalent to 11 multiplied by 11, which is equal to 121. The next example that we're going to do is to calculate the square root of 36 and the square root of 144. So if we start off with the square root of 36, we're trying to figure out what number we have to multiply by itself to give us 36, which is of course equal to 6, since 6 multiplied by 6 is equal to 36. Similarly, with the square root of 144, what number do we have to multiply by itself to give us 144? The answer is 12, since 12 multiplied by 12 is equal to 144. Now, this last question here is a bit of a different one, but it's a good one to get your mind thinking a little bit more. The question here is, what happens to a number's square when you double the original number? Bit of an interesting one in this case. Now, before we get into the algebraic means behind it, let's just do a few test examples and we'll just see what happens. So the numbers I'm going to start off with are 1 and 2, because of course 2 is double 1. And what we're going to do is we're going to calculate the square of both of these. 1 squared is equal to 1, 2 squared is equal to 4. So what we notice here is that when we double the number, as in we go from 1 up to 2, what happens to the squares? We actually quadruple them. In other words, we multiply them by 4. Let's do another test and see if this holds up as well. Let's start off with 3 and 6, because again, 6 is double 3. Now, let's compute the square of both of these. 3 squared is equal to 9, 6 squared is equal to 36. So once again, with the original numbers 3 and 6, all we've done here is we have doubled these. But then what happens to the squares? We go from 9 up to 36, which again is effectively a quadrupling. So again, a multiplication of 4. You can test out as many different examples as you want with this, but the result will always be the same. When you double a number, its square is multiplied by 4. Now, if you want to have a bit more of an algebraic way of thinking about this, let's look at it this way. Let's start off with a number x. And to double this, we would then have 2 multiplied by x, or in other words, 2x. The square of x, or in other words, the original number, is x squared. The square of 2x is equal to 2x all squared. And if you know your algebra, then you know that this can get turned into 4 multiplied by x squared. And we do that by applying the square to the 2 and then to the x as well. And so what we can see has happened here is when we double the original number, as in we go from x to 2x, then the square goes from x squared up to 4x squared. Or in other words, when we double the original number, we multiply the square by 4, which is exactly what we saw with these two situations up here. So we've got two different ways of thinking about this. You can either go through it with actual test cases, which we did in these two examples here, or you can think about it in a bit more of an algebraic sense. There isn't a right or wrong way to go about a question like this. It very much depends on how comfortable you are using algebra in these very, very early stages. If you're not comfortable using algebra yet, that's 100% fine. These test cases that we did here are more than enough to answer a question like this. But if you would like to push yourself a little bit more with the use of algebra, then this second method here of answering this question is still a very, very good one. Alrighty, let's summarize what we've learnt today. So in this video, we defined square numbers, aka perfect squares. Square numbers are numbers which can be produced by multiplying an integer, or in other words, a whole number, by itself. The process of multiplying a number by itself is called squaring. That is, squaring 7 means 7 times 7, or in other words, 7 squared. Thus, we can calculate square numbers by performing 1 squared, 2 squared, 3 squared, and so on. We explored how square rooting a square number always results in an integer answer. This is because square rooting is the reverse process of squaring. For example, 3 squared is 9, therefore the square root of 9 is 3. Finally, we calculated square numbers and square roots in some example questions. And that's it for now. See you in the next video.